Greetings. I am Maximus Cawthon, and I am the project manager, and I will be starting off with the introductions. So today we will be talking about the NASA Mars lander final report. We are the Flying Waffles. We'll have a quick little overview. We'll have our introductions, our background, the requirements, final design, manufacturing activity, test results, and then our conclusion. So for our introductions, we are the Flying Waffles. That is our company name. I am Maximus Cawthon. I am the project manager. We would then have Connor Heller, who is our verification slash test manager. Santiago Natera is our construction manager. And James Monaz is our construction manager, second construction manager. So this is the RFP that was provided by NASA describing what we should be doing with our tasks. So, quick little overview. We'll just be competing with other contractors for a landing, basically. So, our requirements, we should be able to deliver the astronauts to the surface of Mars. On the performance, it should be recorded during on launch day. It should be able to carry two pilots, which are eggs and shall be reusable. The vehicle, these are the requirements. So the vehicle should be able to survive an impact of a 12-foot drop. The vehicle should be able to protect the two astronauts, Humpty and Dumpty, from from damage, weighing up to 59 grams each. The demonstration vehicle should allow the eggs to be loaded and unloaded in less than a minute. Only the approved materials list and the project guidelines should be used in the vehicle. The vehicle must be within the $15 budget. Um, it's going to be dropped on tiled floor, and we can have a maximum of two salvage materials.
Hi, my name is Santiago Natera, and I am the construction manager one for the Flying Waffles team, and for the Mars Lander project. And I'm going to first be talking about our final design. So the design we went with was a parachute type device where we used a Starbucks paper cup to serve as our base, where we put the pilots inside, and we connected that with tape with four plastic bags to create a parachute to decrease the landing speed. The way we connected it was creating four. First we tied the tape super tight together. We created four holes that inside the cup, and then we tied the tape inside, tying it with the parachute. We also covered the paper cup with bubble wrap, and tied it with rubber bands to soften the blow for when the cup lands on the ground. Inside the cup, we also put paddings from cotton balls for the pilots to fill the space inside the cup, and also for to soften the blow inside the cup. And I create three different views: the front, inside, and back, to best illustrate this, as you can see here. So for the next thing I'm going to talk about is our manufacturing plan. So the items we used for this construction for the device is tape, 4 square foot of bubble wrap, 4 plastic bags, 10 rubber bands, 30 cotton balls, and the salvageable material is paper cup. Thankfully, we did not have to change our manufacturing plan last minute. All the materials were there, and we were able to use it. And this shows all the materials we used for the device. So next, I'm going to be discussing about our construction plan. So to begin with, we plan on having two of our teammates to cut the four plastic bags together to create the parachute, and then the other two to tie the tape super tight to create the string, the suspension lines to connect the parachute with the cup. Then after that, we punched four holes inside the cup to then tie the tape with the parachute. We then secured the cup with bubble wrap and wrapped it around with about 2 or 3 rubber bands. After that, we at least tested the device twice to make sure it was safe for our pilots before we actually done the actual test. Then we filled the inside the cup with at least 10 cotton balls to place our first pilot, and we put at least 6 more to place our second pilot. After that, we release inspected lander, ensuring the lines are strengthened so it doesn't rip or anything, and all the compliance for the project requirements. And that's all for today.
And I am construction manager number 2. Today I'm going to be going over some of the changes that might have been made and any problems that we might or might not run into. So during our construction, there actually weren't any changes that were made to our rover as the original plan had described. All our parts were shipped on time and in orderly fashion, so that wasn't a problem. Everything we had ordered was also present, so we weren't missing any parts. The only problem that our team might have faced was one of the plastic bags. As we were constructing the parachute for the plastic bag, we noticed one of the bags actually had a tear on it. We fixed this by simply just adding a piece of tape over it. As the construction went on and we got to the final creation of the rover, we tested the parachute to make sure it actually worked, since it had that damage to it. We double sealed it with tape to ensure it wouldn't break during launch, and everything went all fine according to plan. Here we have a front, top, and side angle of the rover itself. I'm going to be going over some of the obvious and not so obvious parts. Here on the left picture, you can see the full image of the rover, the cup, the padding underneath, and the bag connected to the strings. So pretty much we just had a Starbucks cup, which was the capsule for the pilots. Inside, where you can't see, we had cotton balls that were protecting the pilots from the surrounding and from each other. Underneath that, we put bubble wrap on the exterior of the cup to soften the landing. And to reduce force, we put a parachute to add more air resistance. Here in the second image, you can get a better, clear view of the top of it. You can see more of how the parachute system works. As you see, there's 3 main points of string connected to the cup. From there, we tied those strings onto bases of each bag, and we connected the bags from each other on the top, which was able to make the parachute. On the third image, you can kind of see how even we had the cup. We made sure to balance the bubble wrap fairly around all of it so there's no uneven parts that might be able to take more damage.
Good day. My name is Connor Heller, and I am the Test and Verification Manager for the Mars lander tested on July 29th. Before testing the lander, we had to make some measurements. It was a launch height of 12 feet, and the vehicle was 96 centimeters long, 45 centimeters wide, and 57 centimeters tall. After this, we then started a 1-minute timer, loaded the pilots, and recorded the drop time, 58 seconds for our first drop. After loading, we released the vehicle. Immediately on impact, we recorded the unload time as well, 20 seconds for drop 1. We repeated this process for the entire loop of the second drop, returning the vehicle to the launch point, reloading, dropping, and then unloading as well. Drop 2's reloading and unloading time were 40 seconds and 15 seconds respectively. The following is the test results from the lander. Here's 1. And here is 2. Looking at the outcomes, in drop 1, both Humpty and Dumpty came through with no real damage, and the vehicle itself showed no noticeable harm, a perfect result. In drop 2, the vehicle again held up fine with no issues, but Humpty suffered a crack on impact. So across the 2 drops from 12 feet, the vehicle structure itself was consistently reliable, but the pilot protection only succeeded in 3 of the 4 outcomes.
And I am back. I will be doing the concluding comments and takeaways. So, our design summary: our landing vehicle had a large parachute made up of cut plastic bags to slow its fall. The pilots were put into containers that was also wrapped in bubble wrap to absorb whatever impact was left. Our assembly effort: we cut the plastic bags flat, tape the plastic bags to make one large sheet, leaving some split handles off the side to connect to the cup later. Cut holes into the cup, tie the split handles through the holes of the cup, place a layer of bubble wrap in the cup, place the first pilot inside the cup, and then another layer inside of the bubble wrap. And then we put the second pilot in the cup, and then we would release it from the top. The test results that we got from our AI analysis First, I'll talk about the test results. The test concludes that our landing vehicle was a bit faulty, failing on the second test. So there was a minor crack in the pilot's condition. So some work needed to be done before we are to use it. And for our AI analysis, extracted data, pulled the metadata, sampled the frames, build a motion difference signal to locate the impact objectively, visually review frames around that point, and cross-check the timing against the visual read. We had no DD250 document was uploaded, so nothing came from the paperwork. Every value traces to the video data, the motion signal, and direct visual inspections. Uncertainties that was no scale reference in either clip, so drop height can't be computed for pixels alone. Handheld camera motion adds noise, so impact timing is accurate to 1 to plus or minus 0.1 seconds. One clip is trimmed near impact, so its pre-impact timing isn't recoverable, and video resolution limits damage detection. Fine cracks below that resolution will be shown. Rework and design takeaway, both tests hit within 0.02 seconds of each other from the same height, comparable impact energy, and neither showed vehicle damage. Even with test two's tilted landing, that points to orientation control as the bigger risk factor here, not drop height. Confirming it, we would need the D250 record, close-up post drop shots, and load and unload timing, none of which the video provided. But for our first test, we had our landing orientation, which was upright, and our pilots were still intact. But for our second drop, they landed a bit tilted, leading to damage to the pilot. Design rework effort. If we were to resign this, we would make a bigger parachute to catch more weight of the air, as to make it closer to the body of the vehicle, so it catches the air faster. And that is the end of our Project 3 final report. Thank you so much for watching, and I hope you guys all have a nice day.